Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry for you. How are you all? Can you all able to hear me? Can see me? Nice promo, isn't it? Okay, bachcho, welcome to one more session. Most expected 1000 important questions from the NEET examination, the series from Infinity Lane YouTube channel. Wow, today we are going to discuss about the equilibrium NEET questions part 3. In the thumbnail it is given chemical equilibrium, but it is equilibrium part 3. In these 3 sessions, first session we discussed about chemical equilibrium, second session we discussed about concepts of ionic equilibrium, some questions. And in today's session my agenda is going to be little bit quick revision of ionic equilibrium concept and some important multiple choice question, most expected multiple choice question from the ionic equilibrium. Are you ready? Well, so dear students who are there in online, just come and give a thumbs up and fire emoji in the class. Well, so in the equilibrium NEET questions, we have to consider so far when NEET inception is given by Infinity Lane on YouTube platform, we discussed all chapters thoroughly. And hi Nandu, how are you? And we started NCERT Express, NCERT line by line, all topics has been completed. Now the students are facing an issue like, you studied well, आप अच्छा तरफ पढ़ाई किया. When you start answering questions, you have some kind of issue like how to crack that question. So you are not able to answer the questions. For that, NEET most expected 1000 question series is launched. In that, every day 1:30 to 3 o'clock we are discussing near about 35 to 45 questions, and if you take the 45 days program, it comes around near about 1500 questions. Can't you think 45 questions, among them 1500 questions, can't you see the same model in this NEET examination? Yes, that is our target with a lot of experience, and we segregated these questions and giving you the best for your content. So get ready, and every time whenever you are doing some concept question based, it is very good to revise once all concepts and start the questions. That's my plan. Are you ready with us? Nandu beta? Yeah. So before we start, I just want to say oath of the day. What is oath of the day? Simple, crack your NEET. Spider-Man, preparations I'm scared. No, to avoid that scary, I just want to give you little bit concept revision, then questions are being given. Is that fine? Don't worry. We are here to help you a lot. Fine. Now crack your NEET examination. Take a pen and paper. Every day 1:30 we are preparing 35 to 45 questions. So you solve along with us, give the answer in the chat box, and if you give the right answer, well, if you give the wrong answer, you are learning from the mistakes. I am going to explain you what is your wrong, so that you are academically you are going to do the best. Right? How are you doing then? So please like this session, share with your friends, and subscribe to Infinity Learn NEET YouTube channel. And in the Google App Store, you just see Infinity Learn app and you download it, and you will be enjoying live classes, mock test, and create your own test, and 24/7 doubt resolutions. It's full free of cost. Everybody can enjoy it. So today's topic of interest, I don't want to give so many promotions. So let us go into the content, and we'll discuss short recapture about ionic equilibrium concept, and we'll start questions. Ready for that? Fine. Nandu, come on. So in the ionic equilibrium, the equilibrium principles are applied for these aqueous solutions. For that, you have Arrhenius concept of an acids and bases. According to Arrhenius theory, acid is a substance which donates. Life is chemistry. I am fine. How are you? How are you? Life is chemistry. I forgot your name. You used to attend the classes regularly long ago, and you took a break and you are coming again. Your name is so familiar, but I am not able to recall your name. How are you, beta? Right. So acid, according to Arrhenius theory, acid is a substance. So the channel only for NEET. What about MSET? अरे MSET NEET दोनों को क्या फर्क पड़ता है? Chaitra, yeah, good afternoon. And base is a substance which provide OH minus ions in the aqueous solutions. This Arrhenius theory is only applicable for aqueous solutions. So you can say HCl gives rise H plus Cl minus is an acid. Ramesh, I forgot it. Okay, and sodium hydroxide, sodium plus and OH minus, right? And H2SO4, 2H plus, calcium hydroxide, 2OH minus. So they are only applicable in the case of aqueous medium. You can say applicable only to the aqueous solution, and basicity of NH3 is not explained. That is a defect and the limitation of Arrhenius theory. Okay, right. So what is the meaning of that emoji, Nandu? Now talking about Brown-Lowry concept or a proton concept. Arrhenius concept is only applicable for aqueous, whereas Brown-Lowry concept is applicable for aqueous as well as non-aqueous. It could be any solvent. So it is also called as Brown-Lowry theory is also called as solvent theory. Okay, Chitra. Now according to this, acid is a substance which donate H plus ion. H plus ion means it is a proton, and base is a substance which accept H plus. A proton donor is an acid and a proton acceptor is a base. Nothing. Okay. Okay, now let us see here. You want to say HCl is an acid. You want to take water, unless a donor and acceptor is there, you can't define equilibrium. So it is said to be H3O plus and Cl minus. Now you just see this is an acid one and this is an acceptor now. So it is said to be base 1 and it is going to be acid 2. And it is going to be base 2. Okay, now this pair you can see this one and this one is said to be a conjugate acid base pair. Conjugate acid base pair. And when you talk about this, base 1 and acid 2, again a conjugate pair. Then how do you say this? Proton acceptor and proton donor? Well, so if you consider an acid, इससे एक प्रोटॉन हटा देगा, सो ताकि आपको मिलेगा conjugate base. CB stands for conjugate base. Ebenzi, hi, I am discussing here Brown-Lowry theory. At least thanks for your asking that you don't understand. I am going to explain you Ebenzi for you. Right. Water dual character. ये proton दे सकते हैं, proton ले सकते हैं. So Ebenzi, you said you don't understand because some Hindi is used. Right. You can say acid is a substance which donate H plus according to this theory. And base is a substance which accept H plus. So to explain that, HCl is dissolved in the water, so that H plus from here is donated, so it is said to be an acid. And he is accepting H plus, so is a base. Let's go into the other side of this equilibrium. This is a H3O plus now is capable of donating H plus. So it is said to be another set of an acid, is say acid 2, and he is capable of taking H plus, so it is said to be an acceptor, so it is a base 2. And you consider this set before the arrow mark and after the arrow mark, you can say a pair of acid and a base. So that pair is called conjugate acid base pair. And in that, how do you say an acid? If you remove H plus from it, you are going to get conjugate base. CB stands for conjugate base. Now if you say a base, if you add H plus to it, you are going to get its conjugate acid. Of course, let it be any language. So, as long as the students are comfortable in their language, English is going to be the universal understanding language. But in India, majority of the students can understand even Hindi. So, I am going to discuss this concept both mix in English and Hindi. Is that fine? Okay. If you don't understand any fragment, please let us know. So, Abenzi, hope you understand the Bronsted-Lowry concept of proton theory. Just I want to confirm. And as far as the NEET examination is concerned or any part of examination, I just want to say a golden note. A weak acid will have WA stands for weak acid, will have its strong conjugate base and vice versa. Chitra, right? Suresh Kumar, hello. Now if you want to say HCl is an acid, HCl is a strong acid, and its base is going to be, this is a weak base. Got it? Amyan, hello, how are you? Okay, एक बार हाय बोलने तो चलेगा, बार बार हाय बोलने तो स्पैमिंग मत करना. Don't spam in the chat box. Once you said hi, welcome to the class. So let's see. Further moving ahead, we just want to talk about the Lewis acid. Ebenzi, fine. Amyan, please stop. So let us maintain the decorum in the chart even. Okay, HCl, H2O gives rise to H3O plus and Cl minus, it's perfect. Nandu, okay, right. So students attending this class with a lot of enthusiasm and their ambition. Okay, so in the chart box they are discussing a valuable content and their feedbacks and their doubts are being discussed. So if you use this chart box for the other reason, right, so it is going to be spam, right, so which is not actually comfortable to the class, right. So please follow the chart. Okay, Hafsa Rafiq, hi bola, good afternoon, good afternoon, good afternoon India, right. So according to Lewis theory, so far we have seen Arrhenius theory, after that Bronsted theory, now we are into Lewis theory. Yeah, yes, hi, I said hi now. Okay, Lewis acid base theory. According to Lewis acid base theory, acid is a species which accept electron pair. Okay, and base is a species which donate electron pair, and complete transfer of electron from a donor to acceptor is called a neutralization, so that it is going to form a coordinate covalent bond. So what is the kind of acids? Electron deficient species, cations, and the one which has a vacant orbitals in it can accept an electron. Any factor which makes to accept the electron is an acid. In the examination, you will be having a very good kind of questions like which of the following is a Lewis acid, which of the following is a Lewis base, kind of things will be there, right. Abenzi, fine. And base is a species which donate electron pair. Electron rich species, the species which has the lone pair of electron on it, and species negatively charged it can be. Exactly, Nandu, right. Sir, please pray for me for tomorrow is my 10th board examination. God bless you, all the best. आपको भगवान अच्छा करेगा. Okay, come on. So let us focus this. Let us focus this. We pray for everybody's well-being, academic well-being. Okay, God bless you all. Right. Conjugate acid-base pair. So that is more important thing. So the species which differ by one H plus is called as a pair of conjugate acid base. Yes, one proton differ. Conjugate acid, add H plus. So that you take some species, you add H plus, now it is going to get its conjugate acid. Similarly, conjugate base, you remove H plus and OH minus conjugate acid H2O ka, just you apply the same, right? And NH4 plus conjugate base NH3, right? This slide can help you a lot. This slide can help you a lot. Okay, Nandu, Suresh Kumar, Ramesh, where are you, Ramesh? Come on. Now, if a bronzed acid is strong, then its conjugate base is a weak, and vice versa. We discussed that. Abansi, Aman, come on. And you can see ionization constant. Moving ahead, and multiple choice questions are ready just ahead. Okay. So, when you talk about AB in the aqueous media gives rise A plus and B minus. In that you can see at equilibrium 0, when time is 0, so it is going to be C mole per liter and 0 and 0. At equilibrium, let alpha is going to be degree of ionization. So, C minus C alpha is associated with AB and C alpha and C alpha. And it looks little clumsy. I just want to say AB ionizes, gives rise A plus and B minus. When time is 0, so it is going to C mole per liter, reaction is not started yet. As the reaction is proceeded at equilibrium, alpha is going to be the degree of ionization. So, from C alpha is consumed, so that C alpha is produced, C alpha is going to be produced, understand? In the end, PYQs are there, Nandu, not in the end, in the middle only, right? After 5 minutes, mostly 10 minutes, I am going to start PYQs also. PYQs are mixed in that. In the previous class also you asked, right? Okay. So, equilibrium constant K is written as A plus and B minus and AB. So, A plus it is going to be C alpha dot, B minus it is going to be C alpha upon C minus C alpha. Okay, if it is for acid, it is Ka. If it is for base, it is Kb. Got it? So, you can write this is C square alpha square upon C canonical, so 1 minus alpha. So, I just want to strike this square and see, you are going to get K is equal to C alpha square by 1 minus alpha. For a dilute solution, you can directly write this. That is the same thing it is written. Right? Fine. Hope you understand. Clear? Please reciprocate. Hafsa Rafiq, Aman, Nandu, Ramesh and Suresh Kumar, and many students are there. Chitra. If you want to say it is for the weak acid, it is said to be Ka for a weak acid. If it is a weak base, Kb. If the strength of the acid, if acidic strength increases, Ka value is going to be increased. If basic strength increases, Kb value is going to be increased. Got it? Any doubt? Well, now let's move ahead. So many things I just want to discuss. Now, negation theory, that will come across with the Ostwald dilution law. So, ionization constant of water or ionic product constant of water. So ionic product constant of water, it is said to be Kw. So Kw is said to be here the product of H plus ion concentration and the OH minus ion concentration is called as ionic product constant of water. Okay, so Kw is called ionic product constant of water. In this, its value is given as 1.0 into 10 rise minus 14 mole square per liter square, and conditions applied at 25 degrees centigrade. That is true. As temperature increases, Kw value increases, that's well known factor. As temperature increases, Kw value increases. As temperature decreases, Kw value decreases. Everybody focus here. Now, it is temperature dependent for water being in neutral, H plus, water being in neutral, H plus is equal to OH minus is equal to 1.0 into 10 to the power of minus 7 mole per liter. Got it? Fine, beta? Clear? Fine. Good, 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 good. So, you kept quiet. Chitra, Nando, Ramesh. So, when you discuss with me now, I will understand what is going to be done, right? Next. Experimental value, this is given as we already discussed, it is temperature dependent. Okay. And Ostwald dilution law. So, we know that Ka is equal to C alpha square upon 1 minus alpha, right? Now, for a weak electrolyte, weak acid, alpha is very, very less, very, very less, small value. So, that Ka is equal to nearly equal to C alpha square. So, alpha square is equal to Ka by C. Okay, alpha square is equal to, alpha is equal to root Ka by C. So, I mean to say degree of ionization alpha is equal to K by root C, and root K is also taken as a constant. So, this is what is called as Ostwald dilution law. As dilution increases, what happens? The concentration is going to be decreased, right? So, degree of ionization increases. So, I want to say at infinite dilution, concentration nearly equal to 0, then alpha is going to be nearly equal to 1. That is what is called as Ostwald dilution law. This is connected to Kohlrausch law as well. Okay, moving ahead. Excuse me. Moving ahead. Students, if you have any doubt, you can discuss with us. So, it is a live YouTube platform where it is not a radio telecast. It is not a radio telecast sessions. It is a live interactive sessions. I can talk to you, you can talk to me by using this chat box, and so that we can interact each other, so that students will have the better understanding. हम लोग बच्चों के लिए कुछ बड़ा करने की कोशिश कर रहा हूँ. ओके, आप अच्छा तरफ सोच लो, and you can get any doubt, kind of doubts you can clarify in this YouTube channel, बच्चों. Fine. Okay, so moving ahead, common ion effect. When a strong electrolyte is added to the weak electrolyte having a common ion, then the degree of ionization of weak electrolyte decreases. This effect is known as common ion effect. When you talk about a strong electrolyte, इसमें CH3COOH is ionized feebly into acetate ion and H plus. To that, if you add a strong electrolyte like CH3COONA, the equilibrium is shifted in the backward direction. This is what is called as a common ion effect. This is very important. Concentration of common ion increases, the reaction will shift in the backward direction. Just application of Le Chatelier's principle. Now pH scale. pH scale. pH is equal to negative logarithm to the base 10 of H plus ion concentration, and H plus ion concentration is equal to 10 to the power of pH minus pH. Similarly, pOH is equal to negative logarithm to the base 10 of OH minus ion concentration, and OH minus ion concentration is equal to 10 to the power of minus pOH. And also pKa is equal to negative logarithm to the base 10 of Ka, and pKb is equal to negative logarithm to the base 10 of Kb, and pKw is equal to negative log to the base 10 of Kw is equal to 14 at any temperature. Here pKw is equal to negative log 10 power minus 14, pKw is equal to 14 at 25 degrees centigrade. Mind it, this is very, very important. So the scale is given by Sorensen, and this scale indicates relation between the pH and pOH. So Kw is going to be H plus is dot OH, it is all temperatures, this is true. So it's okay. So I just want to complete the concept, that's the reason why. So what I mean to say, a benzene, you just talk to me so that I can modulate my speech, right? So if you want to take this negative log Kw, it is going to be negative log OH, H plus and OH minus. So it is going to be pKw is equal to pH plus pOH at all temperatures. It is true at all temperatures. So that it is going to be 14 at 25 degrees centigrade. And the pH scale is just to say, if the pH is 7, it is said to be neutral, and the pH scale can be 14, it is the maximum. pH scale 0, it is going to the minimum. So pH scale range between 0 to 14. Chitra, it is this scale is only applicable at 298 Kelvin, Chitra said. Okay, Nandu, fine. Why you all kept quiet for a while? If anything less than 7 is said to be acidic, anything greater than 7 it is going to be basic. Fine, Chitra. And if it is a neutral, it is said to be 7, and it is going to be pKw by 2. And moreover, you just want to say pH can be calculated for the NEET examination. The scope for calculation of pH is given in these 4 aspects: pH of the strong acid and strong base, mixture of strong acid and strong base, mixture of weak acid and weak base, mixture of weak acids, mixture of weak bases, and salt hydrolysis, and buffer solutions. And I just want to say mixtures. I don't want to decide anything here, any kind of mixtures you can say. Yes, Chitra, right. Nandu, we will see now the pH of the mixtures, strong monoprotic acid mixtures. And in that, I just want to say example KOH, okay, HNO3, this is want to say HNO3, HNO3, and you can say NaOH, okay. So for that pH is equal to negative log H plus, and pOH is equal to negative log OH minus, and concentration you can say what is H plus and OH minus. So here H plus and OH minus are taken as normality. So normality, how do you calculate normality? Normality can be calculated by taking the molarity into some n factor. What is n factor? For an acid, it is the number of H plus ions that is given by one molecule, and for a base, it is the number of OH minus ions given by one molecule. Nandu, fine. Now, let us say if H plus concentration or OH minus and concentration is less than 10 power minus 6, then you consider the ionization of water. If it is greater than 10 power minus 6, then you can take the concentration of the acid or a base. That is a simple method. Okay, pH of a mixture, you can say case 1, pH of a mixture of two higher strong acid solution mixture. Okay, so that you can say H plus ion concentration is going to be N1 V1 plus N2 V2 by V1 plus V2. Okay, now if you take the case 2, in this case 2, pH mixture of two or more strong bases, you can say OH minus ion you have to calculate in the same way you can calculate the POH, then you can calculate pH is equal to 14 minus POH. And case 3, pH of mixture of strong acid and strong base, a little bit confused. Okay, so here I just want to say this is a different version. I just want to give Na is stands for normality of an acid. NB is said to be normality of base. VA is said to be volume of an acid. And VB is said to be volume of base. Volume of base. Yeah. So there are three cases. I just want to say, Chitra, carry on. Here you can see if NaVA is equal to NbVb, so the pH is going to be 7, it is neutral. Doubt is clarified. If NaVA is greater than NbVb, then acid is dominating, so that what I have to say, pH is going to be less than 7. Now let us see, if NaVA less than NbVb, then base is dominating, pH is greater than 7. See how beauty the chemistry is. Now we can see it is less than 7. Now how to calculate this pH? So this pH can be calculated by taking the H plus ion. How? NaVA minus NbVb upon Va plus Vb. So from here you can calculate the pH. In this case, this is more, so that OH minus ion concentration will be left in the solution. So it is going to be NbVb minus NaVA upon Va plus Vb. See, from here you can calculate POH. From here you can calculate POH is equal to negative log of OH minus ion concentration. Then pH can be calculated 14 minus POH. You see how beautiful the chemistry is. NEET examination, definitely you can get very good score if you follow this concept without any gap. Any doubt? It's a very good thing, no? It's a very good thing. Agree with me? Now, fine. Let's move ahead. Salt hydrolysis. You like this slide? You like this slide? When acid react with base, it is going to give rise salt plus water. So this is what is called as a neutralization. Neutralization, right? So salt hydrolysis is the reverse of neutralization. So when salt plus water react, gives rise acid and base. So salt hydrolysis exothermic process. No, it is exothermic process. So the reverse is supposed to be endothermic process. It is endothermic process. Therefore, increasing the temperature, the extent of hydrolysis also increases. That's very, very important. See how logically the statement is given. That is the beauty of chemistry. Agree? Fine. Now let's see if the solution is taken. If the solution is basic, let's say sodium carbonate, it gives rise NaOH, it gives rise H2CO3, but it is a weak acid, it is a strong base. So the solution is strong always dominate, my dear students, in the equilibrium. So the solution is going to be basic. Simple trick to memorize this. Now talking about the neutral solution, Na2SO4, it gives rise sodium hydroxide, it gives rise H2SO4, both are strong. Okay, Ka and Kb relation is equal to Kw. Okay, and it is said to be neutral. It is said to be neutral. So strong salt formed by strong acid and strong base is neutral. Salt formed by strong base and weak acid is basic, and the salt formed by weak base and strong acid is acidic. Ammonium nitrate. Ammonium ion gives rise ammonia, nitrate gives rise HNO3. So by looking at that salt, you can say whether it is a neutral or acidic or a basic. Which of the following is an acidic salt? Which of the following pH is the minimum? Everything can be asked for this kind of NEET examination. Now, hydrolysis of salt. In that cation hydrolysis from base like cations, sodium plus, potassium plus, calcium 2 plus and barium 2 plus takes place. Well, anionic hydrolysis from an acid gives rise, these are the anions. And types of salts, you have salt of weak acid and strong base, and salt of strong acid and weak base, and salt of weak acid and weak base, and salt of strong acid and a strong base. By looking at this, pH we can say is ka pH greater than 7, and pH is ga less than 7. Salt of weak acid and weak base, pH in the vicinity of 7, not exactly 7. It is depending upon its relative Ka and Kb value, and its pH is, of course, it is going to be 7. Exactly 7. Understand? Clear? And let us discuss a very important thing about this salt hydrolysis. This is the super awesome and important table. Everybody take a snapshot. 3, 2, 1. Make it fast. Take a snapshot so that we will discuss it. So the salt of the strong acid and strong base, no hydrolysis takes place, so that it is neutral. If you talk about the salt of strong acid and weak base, so it is going to be ammonium chloride is the well known example. Here it is sodium chloride is a well known example. If the cationic hydrolysis takes place and it is acidic, Kw. So hydrolysis constant, always remember this is the trick, Kw upon K weak, and degree of hydrolysis H, that is going to be root Kh by C, and pH is going to be 7 minus of pKb minus log of log concentration is more than strong acid kernel, less than 7. Chitra, I am correct. Okay. Now, and weak base and strong base CH3 weak acid and strong base. Okay, CH3, here it is CH3 and COONA and CH3 COONH4. In this, it is Na and it is going to be weak base. Bas. So in this anionic hydrolysis takes place. Solution is basic and the pH can be calculated 7 plus of pKa plus half log C. And for this COONH4, it is going to be both cationic and anionic hydrolysis takes place, and it is nearly neutral but not exactly neutral. And hydrolysis constant, no? Degree of hydrolysis is equal to Kw upon Ka dot Kb. And what is the importance for this? Degree of hydrolysis independent on the concentration of the salt. But here concentration badega, hydrolysis is also decreased. Okay, it is coming in the denominator. So the pH is going to be 7 plus half pKa minus half pKb. It is not included in the concentration term. So that is the style you need to understand. Quick revision for one topic and we'll get into the numericals first. Okay. Now before going for that, two more things are left: solubility product as well as buffer solution. Now buffer solution which raises the pH value on the dilution or anything you do, so or any addition of salt or base. So you have simple buffer. A simple buffer is an aqueous solution of a salt of weak acid and weak base. And a mixed buffer, so you have a mixed buffer. Mixed buffer is nothing but, it is a mixed buffer is nothing but it could be acidic or it could be basic. Acidic buffer is a mixture of weak acid plus its conjugate ion, and weak base, salt of weak base and its conjugate ion. So you can have various examples, and buffer pH can be calculated by using Henderson-Hasselbalch equation. Okay, so we'll talk about Henderson-Hasselbalch equation. For acidic buffer, the pH is equal to pKa plus log salt. Salt, this is the conjugate base, means it is a salt by acid. And for basic buffer, POH is equal to pKb plus log conjugate acid, means it is all salt upon weak base. Okay, well, so from here you can calculate the pH is equal to 14 minus POH, है ना, क्योंकि pH plus POH is equal to 14. So in a single shot all the formulas are being revised. Agree with me? And also buffer capacity. Buffer capacity is the ratio of number of moles of acid or base that is added to the buffer to change the pH of 1 unit. So based on this buffer capacity, the numericals can be asked in the NEET examination. And also we are almost done from the concept wise. So before going for that, a small promotion: NEET 2025 All India Test Series pack is available on the Infinity Learn YouTube channel, right? So you have 27 AITS examinations, 20 online NEET examinations, and 3 physics, chemistry, biology books along with video solutions, detailed solutions, and your performance is benchmarked with Sri Chaitanya students. Why late? This is limited time offer. It is getting, it was 5,999 coming to 2,999. When you apply the coupon code YouTube 50 off, then only you are going to get this offer, right? So all the best, my dear students. It is very important to go for any test preparation during this preparatory time. Now moving ahead, now we are in the multiple choice questions. Quick, and I want you to give the answer. Select the correct option from the following. pKw increases with increase in the temperature, pKw decrease. You are asked to select the correct options. Correct, उसमें correct क्या? उसमें correct क्या? So it's a trap actually. Kw is equal to 1.0 into 10 to the power of minus 14 mole square per liter square. This is true at 25 degrees centigrade. So as temperature increases, Kw value increases, right? So also you see pKw, students, pKw is equal to negative log Kw. So as Kw value increases, pKw value decreases. Fine. So I just want to say pKw value decreases with increase in temperature. It's a trap actually. Any doubt? Any doubt? My answer is B for this question. Fine. Now, in the following, which has the highest maximum degree of hydrolysis? Highest degree of hydrolysis. Ammonium chloride. It's a salt of strong acid, and weak base. है ना? Yes. Now degree of hydrolysis, when you see in the previous one, degree of hydrolysis, look at this, degree of hydrolysis for a salt of strong acid and weak base, degree of hydrolysis is going to be root Kw upon Kb dot C. Now moving ahead, so I want to say here, I want to say here degree of hydrolysis root over Kw Kb dot C. So degree of hydrolysis is inversely proportional to root concentration, right? So concentration कम है, hydrolysis ज़्यादा है. So this is the logic. So concentration जिसमें कम है उसमें कम है. So my answer is going to be here, it is going to be C, not here, it is going to be C. Got it? Clear? Yeah. Now here it is going to be, in which of the following one has the lowest value of degree of hydrolysis? I just want to say, for degree of hydrolysis, who is this? It's a salt of weak acid plus weak base. So such type of thing, degree of hydrolysis is given as Kw upon Ka and Kb, and in this it is independent on concentration. So as this is independent on concentration, same in all, understand? Chitra, doing so, NEET examination, this is the way the questions are being asked. Now answer is D. Now let us see one more. In which is the correct option for hydrolysis constant of ammonium cyanate? So ammonium cyanate, and let us talk, he is ammonia and he is HCl, and it is a weak acid and it is going to be weak base. right? It is a weak acid and it is going to be a weak base. So, weak acid and weak base, hydrolysis constant. So, for this hydrolysis constant, KH is going to be how much? KW, KH is equal to KW upon Ka into Kb. So, check the answer. Here it is going to be B. Got it? Chitra, fine. Hope you understand this. Students, focus. I want you to give them answers in the chat box. Answers in the chat box. And also, if one equivalent of a strong acid is added to one equivalent of a weak base, the resultant solution is. It's a super awesome question. It's a trap, mind it. The questions are asked in a trap like things, right? Fine. Now, your answer is going to be, then give the answer, Chitra. Nandu, Evanzi. Yes, opportunities are wait. Gear up, NEET success. Enroll now in NEET test series. It is there in the pinned messages. Students, comment. Waiting for your answer. Waiting for your answer. Press like and bell button. Chitra Noel. Okay, let me give you. What is this? One equivalent of a strong acid. So HCl I just want to say, and one equivalent of weak base, ammonium hydroxide I just want to say, right? Thank you very much. Thank you, Chitra. So it is going to give us ammonium chloride plus water. Now this is a salt, one equivalent and one equivalent. It is neutralized. There is no more. It's a neutralized. We began fan, right? Prasad, Priya, hi. Now, when you just complete one equivalent of HCl, one equivalent of ammonium hydroxide gives rise ammonium chloride. So there is no more acid and a base. Now we got a salt. That is only left. Now in this solution, it is hydrolyzes. When it is hydrolyzing, it is going to give a weak base and a strong acid. So the pH of the resultant solution is going to be 7. pH of the resultant solution is going to be 7. It is going to be acidic in nature. It is going to be acidic in nature. So the answer for this question is B. So what students think here, it is completely neutralized this, so that the pH is going to be neutral. How? It is not neutral. This is not correct. Okay, this is the correct answer. Got it? Fine. Now, one more question. Hi, V4, not V4. All hundreds of more than 500 students are there in the class. Shout out. Why should I shout? Okay, come on. Select the compound whose 0.1 molar solution is basic. Ammonium chloride, ammonium acetate, ammonium sulfate, sodium acetate. You want to say B here? It is ammonium chloride. It is a salt of strong acid and a weak base, and it is ammonium acetate. It is a weak acid and a weak base, and it is ammonium sulfate, weak base and a strong acid, and it is sodium acetate. It is sodium acetate. I mean to say it's a salt of weak acid and a strong base, so that it is pH is going to be greater than 7. So My answer is going to be here. It is a basic. Got it? No, it is D. Answer is going to be D. Anurag Singh, you come and just go. Now you participate in the class. Where is your energy? Chitra is rocking like anything. Okay. So Priya Prasad and we 4, and let us do one more question beta. How many grams of calcium oxalate will dissolve in distilled water to make 1 liter of saturated solution? Its Ksp value is given. Molecular mass of calcium acetate is given 128. Answer Chitra, your answer was D. I agree. Okay. Now I want you to solve this question. Perfect way, in this perfect way. Chitra no, it is CH, Chitra COYNA, and it is going to be answer beta jaldi, expecting answer. So pH calculations, it's all depend upon the solubility product constant का है. It's all about solubility product constant. Now let's solve here. Answer शायद 0.0032 होगा. I'll going to show you how to solve this. So calcium oxalate CaC2 on ionization gives rise Ca2 plus and C2O4 2 minus calcium 2 plus on oxalate, and the solubility product Ksp is given as Ca2 plus and C2O4 2 minus. Okay, these two is equal to Ksp value is given here. Got it, Nando? Perfect. Now in this case, so the solubility is going to be S and S. Okay, so Ksp is going to be S dot S is going to be S square. So S is equal to root Ksp. On solving, you are going to get 2.5 into 128 into 10 power minus 5. It is in the mole. Multiply with the molecular mass, you are going to get in the gram per liter. Got it? Now my answer is going to be C. 3.2 into 10 power minus 3 or 0.0032. Fine. Nando, Chitra, any doubt as far as this question is concerned? Now, select the sulfides which has maximum solubility in the water. Maximum solubility in the water. I just want to say solubility is directly proportional to Ksp value. This is the trick I have. This is the trick. Yeah, Chaitra, S square. So S is equal to root over Ksp, right? Now in this case, जिसका Ksp value ज़्यादा है वो salt का solubility भी ज़्यादा होगा. The salt with highest Ksp value will be having the highest solubility. So, and which is the biggest, mathematically biggest number? Mathematically biggest number. Yes, this is a mathematically biggest number. Got it? So my answer for this question is going to be option B. So this is the trick. Don't leave the tricks given by me in the class. We are here on a YouTube platform conducting the classes to increase the student confidence level and increase your NEET score, and your medical seat is going to be reserved automatically once you work hard. Okay, you only have to study, you only have to do work, and you only going to write exam, and result is yours, and we are just facilitate the system. Chitra, fine? Okay. So, well, my dear students, we had a great swell of today's class, and we'll meet with more stuff in the next class. Tomorrow we'll catch up with general organic chemistry. Ready for that? And as the time is exhausted, we would can discuss some more questions. Okay, we'll have an extra sessions also. So stay with us and please like the sessions and share with your friends and subscribe to Infinity Learn YouTube channel. Thank you very much, and we'll meet again tomorrow. Without fail, you all join. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye bye. Bye, students.